and here's a closer up picture. You can see it here. There's the crescent moon with the new star, or as the Chinese called it, the guest star showed up. All right, this is a remnant. It's called the Veil Nebula, and this was a star that exploded several thousand years ago. And you can see that it's expanded further out in space. In fact, it's still expanding today. You can see this even at a small telescope. You can especially see this side because it's a brighter band of light here, and you can see this gas which is expanding into the space. Here is the most recent one that was visible with the naked eye. This one is this is part of the Large Magellanic Cloud. This is a galaxy, a companion galaxy to the Milky Way. You can't see it from here, you can only see it from the southern hemisphere. But that star right here blew up and became super bright. The interesting thing about this star is it was discovered by a guy just walking. There was a guy that worked at the observatory down in Chile, the Cerro American Observatory, and he was walking between the telescopes and he looked up and goes, "Hey, there's no bright star in that position in the sky." He knew the sky very well. And sure enough, they looked at it, they turned the telescopes to it, and they saw that this was a supernova that had just gone off. This was in 1987. And it was probably the best one studied because it's the closest to us. Now, it's still a distant galaxy, but this galaxy is only about 100,000 light years away, which is fairly close, a couple 100,000 light years away. The closest large galaxy to us is Andromeda. It's about 2 million light years away. So this is relatively close to us, but it wasn't technically in our own galaxy. Here's what we see when we look at that spot. Today, it looks like this. You're like, wow, that's weird. None of that was part of the explosion. The explosion is all in the little dot in the side because within 20 years it hasn't expanded enough, big enough for us to see the details of the explosion. This was gas that was already out there, and as it was spinning with its magnetic field, it lit up this gas and charged it up, and so it gave off light. So the gas was already floating there, and the explosion triggered this lighting up of this circular gas rings. Back in the 1600s, there were 2 of them that were visible with your naked eye. This is one's called Tycho. It's named after Tycho Brahe because he was an astronomer back then in the 1500s, and he saw this. The next astronomer who actually worked for Tycho was Kepler, and he saw his own. This was in 1604. So that one was in the 1500s, this was in the 1600s. Both of them were visible with your naked eye. By this point, they didn't have telescopes yet. Shortly thereafter, 1610 or so, is when they started to get telescopes. But back then, and now this is what it looks like when we see this expanding gas cloud. This is a composite picture. These are X-rays coming out in the blue and the green. These are high energy, low energy X-rays. Visible light, all we see is a little bit of stuff. And this is in the infrared, which is mostly glowing dust as this thing still expands. All right. So, would it be bad for us if a supernova went off close to us? Yes, it would. In fact, supernova going off too close could wipe out life on Earth. Why? Because you have all these nasty things coming out. Neutrinos, you're getting bombarded by a million neutrinos right now and it doesn't affect you. But when you start saying, oh, well, if I have billions and billions of millions of neutrinos, they can interact with your body. X-rays, we know X-rays are bad. They go right through you and cause damage. Usually we're protected by our atmosphere. But if you have such a high amount of X-rays, even our atmosphere can't protect us completely. Gamma rays are even worse, and they come from those nuclear reactions. They come from that core that was so hot, it's giving off all kinds of gamma rays. They're just really bad. Again, we're usually protected from these, but if you overwhelm our atmosphere, we're in trouble. Cosmic rays are actually particles. These particles come flying out like protons, neutrons at such a high rate of speed that they can go right into our atmosphere. They run into other particles and they can cause a whole chain of things. You get enough cosmic rays, it's really bad for your body too. Not only that, it doesn't directly have to affect us. If they don't get all the way to the surface, they can still destroy our ozone layer. You destroy our ozone layer, you let the ultraviolet radiation through, then we have to worry about cancers and things that kill off over time. Okay? One thing that people said, well, what if one had happened in the past? Could it have caused something that we could see, like an extinction event on the Earth? And they realized that, you know, the biggest ones that are going to be in trouble if there was a supernova that was very close. And we need it close, we need to be within about 100 light years or something to really affect us. Anything that's on the order of 400 or 500 light years, 1,000 light years away, not going to be a problem. That's why Betelgeuse right now, which is a star in the constellation Orion, seems to be very active. It could blow up tomorrow. It could still be 1,000 years from now. We really don't know. But if it did, it won't hurt us at all. In fact, it's far enough away, it's not a problem. It will just be nice and spectacular to watch. Astronomers would love to see it just for the fun, cool thing of it going off. But if one came off close to us, and these effects happen, the thing that would hurt the worst, or the animals that would get hurt worst, are the biggest animals. The bigger animals are going to absorb more radiation, more energy. The smaller ones, probably not affected as much. So they said, okay, let's go back and look in Earth and see if there's certain animals that died off, and when they died off from the fossil record, is there any record of a supernova as a possibility for killing them off? And nobody expected them to find it, but they did. The megalodon. Most people didn't know what the megalodon was until a few years ago, and they made a movie called the Megalodon. I think it's called Mega or something like that. But it was a giant shark. I mean, it makes normal sharks seem wimpy. It could take down whales. Biggest shark ever. But it went extinct. It went extinct about 2.6 million years ago. Okay? Remember, this is in the age of mammals, right? 65 million years ago is when we switched from the dinosaurs. That was our last major impact, our last major extinction event. So 2.6 million years ago, we didn't see a lot of extinction, but these large creatures died off. And they said, well, could it have been a supernova that killed them off? Well, one way to tell is you look for iron-60. Iron-60 is an isotope of iron, meaning it's an iron that has a different number of neutrons than regular iron does. Okay? And what creates the iron-60 is if you have an excessive amount of cosmic rays. All those cosmic rays come in, they can hit the iron, change it to iron-60. So they found, remember this is fairly new, this is only 2018, they found a layer of iron-60 at 2.6 million years ago, the same age that the megalodon died. And they were very large creatures, and we think the largest creatures would have absorbed more radiation and been more likely to be killed off. Not proof, but it's very interesting. You can follow the link and read more about it. Remember, these PowerPoints I use are up on D2L, so you can follow the link to read more about it if you're interested in that. But it probably occurred because a supernova was close to us. Now, people ask, well, is there a star that's got a supernova that's close to us? Right now, no. But all the stars are circling the Milky Way, and so over time we move and we get closer and further away, time being hundreds of millions of years. So at different times in the past we have been closer to stars that have supernova than we are now. One of the advantages to our orbit and our Milky Way is we're in a pretty stable area, so we're not surrounded by this. If we were closer to the center of the Milky Way, there's a lot more stars, there's a lot more supernovas. It would have been probably bad for life to exist. We live in a region where it's fairly quiet, which is a good place to live in the Milky Way. Or you can look at it as a good place to live, or that's probably why we're here, is because this was the place that was conducive for life to occur. All right, so that's a type 2 supernova. There's also a type 1 supernova. Different beast. When a star, like the sun, gets old, okay, its remnant, what we call it, will become a white dwarf. The white dwarf is about the size of the Earth. It's going to be made mostly of carbon and some oxygen. Very, very dense. Not as dense as a neutron star, but very, very dense. You're pretty much taking the whole sun and you're squeezing it down to the size of the Earth, which is about 1/1,000,000th the volume of the sun currently. So very high gravitational field, solid carbon and oxygen. Starts out really hot, but since there's no fusion, it's kind of like taking an ember away from a fire. Over time, it's just going to cool off. Okay? Now, if for some reason this happened to be a white dwarf, so we have our white dwarf, and it has a companion star, and it's a binary system. Well, then they spin around each other. Two stars will orbit each other, just like the planets orbit. If you have two stars close enough, they'll orbit each other. And if they're close enough, then matter from one of the stars can fall onto the other one. So this star over here, as it's getting bigger, when it evolves, it gets bigger. The material, instead of just getting bigger in space, actually falls onto the white dwarf. Well, if it falls on there fast enough, then that white dwarf gets super hot. It starts to compress it. And the white dwarf can only take so much compression. It can only take about 1.4 solar masses of material. So if the white dwarf is already 1 solar mass and you start throwing material on it, if you get greater than this amount, the white dwarf can't support it. The whole white dwarf collapses.